Hi, my name is Dan Ciruli. I'm a product manager. I run the Service Mesh product management team at Google. We build both our open source version, which is Istio, as well as our product Anthos Service Mesh. I was told I have about 30 minutes today to explain to you what the heck we're doing and why we're doing it and why you should care. Has everybody here heard of Anthos? I assume Aparna did. Oh, yes, I see hands on the back. We are part of the Anthos stack. Anthos helps you manage your operations. It helps you with your service management. Manage the services that you're deploying into your Anthos clusters. And of course, probably someone will be talking to today about the marketplace as well. And of course, this is everywhere. Anthos is everywhere. Where my team fits in is in this middle tier. You want your developers, unless you're working at an infrastructure company, you want your developers doing as little as possible that has to do with infrastructure. You want to move your developers up the stack so they can be more and more productive. And with Anthos, as you've heard, we have an open stack of software, something you can run anywhere that you can go download and run yourself if you'd like. That really the ultimate aim is to allow your developers to build and deploy modern applications as quickly as possible. And Istio fits somewhere in the middle, and Anthos Service Mesh fits somewhere in the middle, and I'm going to explain a little bit about what we do. Capabilities that we add into this platform that should make your developers more productive. And in order to do this, I want to talk a little bit about why we made service meshes in the past. If you ever go to Google Trends and you look at service mesh, you see this just up and to the right curve over the last couple of years. And the reason is that we have a new set of problems that people are encountering as they move to these modern cloud architectures. And the reason is that we've now moved into a distributed world, right? We used to live in the way, I used to build systems that were monoliths, and we would build big, fat executable that essentially sat on top of a database, right? And we would expose that to the world. And a call would come in from, usually it was a web app back then, or a client even, and would hit that thing, and then a bunch of logic would happen, right? Well, there are some real downsides to deploying in that way. Mostly that it's slow, that people who deploy monoliths often end up deploying monthly or quarterly. And in a world where your competition, whatever your industry is, banking, insurance, shipping, manufacturing, if your competition is able to deploy more frequently, then they're going to get features out faster. And in a world where people are choosing their bank not by interest rates, but by how cool the app is, it matters how fast you can get applications out, right? So that's why we're moving to this microservices-based world, is that you can deploy more frequently. You have small teams, they can deploy independently. You can get new features out faster. However, what an application has changed. An application is now inherently distributed. It's running in lots of different pods. It's running maybe in multiple clusters. It's running maybe in a hybrid fashion, right? And because applications have now all essentially become distributed applications, you need a new set of tools to help you regulate, monitor, and secure the traffic between all those different services. And that's where the service mesh comes in. Service mesh is a way to transparently add in a bunch of functionality to your application. The world has mostly standardized on a small number of protocols for communicating between different components in your application. You're probably using HTTP. REST is great. It really made it a lot easier for things to talk. You might be using gRPC. You might be using another TCP-based protocol. And what a service mesh does is on those standard HTTP or gRPC or TCP calls, adds in a bunch of network functionality, the ability to understand the traffic, the ability to secure the traffic, the ability to control where any given call goes. And a service mesh does this in a language-independent way. Anyone who can consolidate on a single language can actually get the functionality that's built into a service mesh generally from some sort of client library in that language. If you can tell every developer in your enterprise, we're all using Java, And we're all going to use Spring, and we're going to use a middleware layer that we're going to compile in that's going to handle all of our security and handle all of our monitoring. You can do that. However, in a world where there are more than one language in your enterprise, using a client library to do that becomes a really inefficient way to do it. And a service mesh lets your developers get the advantage of that sort of functionality without having to compile something in, and just build into that standard HTTP call they're making a bunch of load balancing and fancy networking techniques. So Anthos Service Mesh offers three main pieces of functionality, and I'll go into a little bit into detail on all of them. The first is observability. When you moved from that monolith, where one call came in and then it did all it needed to do and then returned a response, when you move to an application that's now built of 10 or 20 or 50 or 100 microservices, all of a sudden you have a new problem on your hands. And that's, how do you tell what's going on in your application? How do you know when it's not performing well, why it's not performing well? How do you understand if a particular service is slowing things down? So Anthos Service Mesh helps you understand what's happening inside an application. It gives you operational agility. And by operational agility, fundamentally what I mean is the ability to roll out a new version of your application safely without breaking all your users. It gives you the control to basically control where any given call is going to go. It lets you do fancy things like locality-based load balancing, and it lets you do fancy things like fault injection, canary tests, a lot of functionality that basically says for any given call from a service to another service or from outside the internet to a service, how do you control which one that goes to? And then finally, it gives you security. And this is a really big deal that not everyone has quite figured out yet. When you had that big monolith, you had to secure one IP and port, and that was it, right? As long as that was secure, you were safe. When you move to microservices, all of a sudden, you have IPs and ports all over the place that are talking to each other, right? You have lots of communication. And one thing that you're, just depending on what industry you're in, you probably also need to find a way to secure all of those and make sure that you are not allowing any calls to occur that you don't want to. It can make it so you can write policy that says who's allowed to talk to whom. It can make it so that all of the traffic on your network is encrypted, so you can trust that all of your data is encrypted in transit. So these are the three main features that Anthos Service Mesh adds. It does this by using this tool we call a sidecar proxy. When we started the project, sidecar was a term we barely used, but it's really caught on. And it really means something that's deployed alongside your application. Kubernetes has some really nice ways to make this happen automatically, so that when a team deploys into a Kubernetes, into your Anthos cluster, Anthos Service Mesh and Istio, the open source version, can make sure that a sidecar gets deployed. And this thing, you can think of it as just something that sits alongside your workload, and all the traffic from and to that service go through the sidecar. And because all the traffic goes through, and service A places a standard HTTP call addressed to service B, it first goes through a sidecar, and that sidecar decides where it goes. Are there lots of service Bs running? Do we need to load balance between them? Are we running a canary right now? Should I send 1%? Should I inject faults? And do we want to, or do we have fault injection set up? Are we doing any chaos engineering? It does that. And then on the other side, before that call actually gets to service B, there's another instance of the sidecar. Over there, it's doing things like saying, hey, who's making this call? And is this service allowed to call me? Is the traffic encrypted, and does policy require that it be encrypted? Are they over any quotas they have? And assuming that all the answers to all those things are positive, then it allows that call to go through. What's important is that this is invisible to the services. The teams that are writing service A and service B didn't have to do any coding to Istio or to ASM. This just happened automatically. In Istio, the open source project, we also ship a control plane that kind of programs the proxies and tells them what to do. And in ASM, we're building a managed version of that control plane. So what does it give you? Well, first, it gives you really good what we call observability. Observability, how many people are at their first KubeCon right now? Okay, you're going to hear some words a lot. Service Mesh will be one of them, guaranteed. They won't all be talking about Istio. But observability is another one. Observability is a word we've decided kind of as an industry to use to mean understanding how your application's working. What we do in Istio is we gather what we call the golden signals for every app that's deployed into your Anthos cluster. Who knows what the golden signals are? Who has read the Google SRE handbook? Okay, if you're not in operations, that's okay. Your operations team, this is a free handbook that you can get. It's called the Google SRE handbook. And it is literally a distillation of what we learned in our first 15 years on running services. As people move to these modern architectures, your operations people should all download and read the book. In that book, they describe the golden signals. Our operations people realize that if every service is monitored uniquely, it's impossible to run them at scale. It's impossible for one operations team to run multiple services if they're all unique. However, they said, you know what? There's some golden signals that you should monitor for every service. And if you monitor those, then you get a good handle on what most services are doing. And those are traffic levels, those are your error rates, and your latencies at different percentage. So Istio gathers those for you. It gathers logs from every call, so that if something goes wrong with an application, you have enough information for your operations people and your developers to figure it out. And we add traces into every call so that you can figure out exactly what's going on with performance. So Istio does this all out of the box in ASM without having to recompile your application, without having to build new things into your binaries. The next thing it gives you is more agility, better networking, the ability to do client-side load balancing without having to run through external load balancers, because that client-side proxy can do it. It gives you the ability to add retries and timeout policies into your calls without hard coding them in your application. That's a big deal that lots of people don't understand how important that is. For your operations people at runtime to say, hey, we're having a problem. We're going to change, we're having a storage system that's running slowly. Having your operations team have the ability to, say, increase a timeout or change your back-off policy on retry without waking up the developer in the middle of the night and without doing a redeployment. It's pretty amazing. And also it gives you the agility to do things like canary rollouts so that you can make sure that a binary is good and performing well at scale before all your customers are hitting it. And finally, and very importantly, depending on your industry, it gives you security. It gives you encryption in transit on all of your calls. Again, without you having to figure out how you're going to implement MTLS at your company. It gives you the ability to write policy about which services talk to which services. At Google, we talk a lot about BeyondCorp and our zero trust network. We don't trust things on our network. We don't use IP. It is one of the factors we use. But we don't use IP alone, your IP address, to decide whether or not a call gets through. Most companies are literally using that. And what that means, if someone breaks into that network and you're using IP address to tell if something's safe, now they've gotten access to everything in your network. And some of the worst hacks that we've heard of, that's what happened. A single server got compromised, but once they were in the network, they got access to everything. Istio lets you say, no, we're going to have security around every single service. What this is ultimately about is about separating applications from infrastructure and giving you better infrastructure so that your applications team, because if you need security right now, you're getting security, but you're getting it because your developers are working on it. If you need to figure out how to do a canary rollout, your developers will figure that out and they'll implement it, right? If you need good monitoring, someone is investing time in integrating some monitoring tool into your application. But all of that is stuff that they're now kind of building into the application, when instead they could be getting it from infrastructure. It also, as I kind of referenced before, this decouples what happens at development time from what happens at operation time. You want to give your SREs, as you move into this kind of modern cloud world and this Anthos world, you want to make sure you're giving your operators, your SREs, your DevOps, whatever you call them in your company, the ability to do things at operation time that they need to do. Again, whether that's drain a cell, to advance a canary, to change a retry policy. Even if in your company the developers do the operations, There are things like the ability to change that retry policy without having to do a build of your application and a redeploy of your application at runtime is good. So it's decoupling what happens at development time from what happens at operation. And ultimately, all that, all the stuff that we're doing in Anthos is to help you move faster, right? It's because it doesn't matter to me what industry you're in. It doesn't matter if you're delivering pizzas or you're selling clothing, or you're a technology company or you're an insurance company. Your ability to compete in today's world depends on you getting features out faster, right? And it's amazing to see that happening in industry after industry after industry. Software is eating the world. As it turns out, Mark Andreessen was right. And the way you're all competing now is the ability to get that feature out faster. And what Anthos is trying to do is to make it so your developers can move faster, again, regardless of where they're deploying. Okay, that's probably enough slides for now, right? Right? Thank you. I want to show you a little bit. So I've talked a little bit about general, what is Service Mesh and what does it do. Now I'd like to show you a little bit of the UI that we have in Anthos Service Mesh. So Service Mesh is something you install with a Kubernetes cluster. As we say, we have Istio and open source. It's pure open source. You can run it yourself. With Anthos Service Mesh, we're providing the managed version of that. In fact, if you think of open source Kubernetes, and GKE, you can think of Istio and Anthos Service Mesh, right? There's the one you can download, install, run it yourself, or there's the one that we run for you. Included with Anthos Service Mesh is a telemetry piece, and that's what I want to show you today. So as I do this, kind of curious, how many people here are running Kubernetes today? A good chunk of you are, okay. So if you're running Kubernetes, if you've ever seen GKE, you know that when you do a deployment into Kubernetes, into GKE, we give you some monitoring, some ability to tell you, how many nodes are in your cluster, what workloads are deployed to a node. You can see the CPU and the RAM consumption on those things. What you can't see at all is, how's my app doing, right? It doesn't tell you any of the things that are happening up there at L7. I'm going to do it like that, and I'll do some zooming, and we'll see how it works. When you deploy into a cluster that has Anthos Service Mesh, you can see you get a different view of what's going on in the cluster. Here I see a list of the services that are deployed in my cluster. And I can see the list here, but what's really awesome beyond that, as I scroll over here to the right, for each of them, I'm getting, I mentioned before the golden signals. I can see here, I get the golden signals out of the box. So we deployed in here. My developers didn't have to do anything special. The Istio sidecar was automatically injected, and it started reporting data back to Stackdriver. And then this dashboard's appeared. So I can look in this cluster, I can see all the services, and I can see the golden signals right away. So right away, it's a much higher level view. I think of it as you're now seeing your application at layer 7, right? We understand the HTTP connections, the gRPC connections that are happening in your application, and we can tell you things like what the latency is at the 50th percentile and what the latency is up here at the 99th percentile. So it's immediately a higher level view of what's going on to an application. But we can do better than just that, because we can also, by looking at the traffic, see how these services that you've deployed into your cluster are related to each other, by seeing how they are communicating. So we're seeing all the communication that's happening. We're getting a little bit of strangeness here, but I can get a high-level view of my entire application. I can see what is talking to what. I can also zoom down in here, and I can even do things like see what is dependent. So I can see some things have lots of dependencies, and if there's a problem happening in my checkout service, I can see there's a lot that I might have to get into. And I can also see if there's a problem in recommendation. That's a little simpler thing to debug. If I can tell from here, I can actually even see the number of requests per second that are coming from any given client. So when I look at the cart service, I can see that it's getting half a request per second from my checkout service and about 6 requests per second from the front end. So it's a very different view of what's going on in the application. and I think this is my product catalog service. If I click on one of them, again, I can see my golden signals right here, and I can see what's happening. But I can also pop out and look at a service dashboard that gives me good detail into what's happening in this particular service. So if I can see overview here, I'm going to talk about SLOs in just a little bit, but if I jump into my metrics, here I will see a bunch of the metrics that we're gathering. I can choose my time frame. I'm looking an hour right now. I think we store the data for 4 weeks, so you can look back a little bit more. You can break it down, and I can actually break down this traffic by, say, the client that's making the call, the operation, so which of my methods is getting called most frequently. And I can go down here. I have my error rates, which are all 0 right now. That's great. I can see my latencies, again, at different percentiles, break it down, request size, response size. So a lot of information. And even here, start to show things like CPU consumption on the individual nodes. So now we're going down to see the pods that comprise this service and how much CPU they're consuming on different nodes. So as an operations person, I have great view into what's happening. I can also go and see where my traffic is from. If I have inbound traffic, think people that are calling me, and if I have any dependencies, anything upstream, as they say, I would see those listed here. In this case, this one does not have any dependencies. And one other thing that I can tell by looking at this is ASM, Anthos Service Mesh, is telling me here, all the traffic to this service right now, this green lock means, is encrypted. We have MTLS in effect. I might have a policy that would enforce that anyway, but I can tell that in this time frame, all the traffic in here has been encrypted. So it's a very powerful view, and again, a much kind of higher level view than what you get out of the box with Kubernetes. So now I'm going to go back to slides a little bit and talk a little bit about SLIs and SLOs and error budgets and how we use those. So have people heard SLI, SLO, SLA? Heard these acronyms? We use them a lot at Google. An intrinsic part of how we assess the health of the service is agreeing on what its SLIs are and setting objectives for what those are. And occasionally, and I shouldn't say occasionally for many of this, but for some of our services, we offer SLAs, legal agreements. So an SLI is simply a thing that you measure. It's a quantitative measure that you decide is important for your service. We frequently at Google use the golden signals for this. In fact, most services that we expose externally, in fact, everything we expose, we are monitoring these. You might have some custom things about your service that you need to monitor, and that's okay. But for the most part, we would say everybody should be monitoring those golden signals to begin with. An objective is a target value or a range of values for this service, right? And typically our objectives have to do with error rates and latencies, right? We want low error rates, and we want as low as possible latencies. We don't have 0 error rates. We don't expect 0 error rates. When you're deploying anything at scale, you won't see that. However, you do want most of your requests to succeed, right? And you'll want to set a latency, and we measure latency typically at least 3 different levels. At the 50th percentile, what does the average request take to respond to? But we also measured it at higher percentiles, at 95th, typically 99th. For our really high traffic services, we also measure at 99.9th percentile latency, because we've found that sometimes performance bugs don't manifest for everybody, but they manifest horribly for some people. So we set objectives, and it's these things you alert on. You alert when you're out of compliance with an SLO. And then there's SLAs. SLAs are legal agreements. SLA is when we tell you, hey, we will return, we promise you 99.5 or 99.95 or 99.995% of our services will return. Typically, customers like to see these in uptime, and uptime is a really weird thing to measure when you've got a globally available service where different cells can behave differently. We have some ways that we deal with that. It's called windowing, and we'll measure. But typically, an SLA is, it's between you and your customer. Your customer might be a customer of your company, might be a partner of your company, or typically, it's just another team at your company. They're reliant on your service, And you have an agreement to them that you will provide a certain quality of service. And I'll talk about what we do when we violate those agreements. Those are what we call error budgets. We have two different concepts here. There's alerts and error budgets. And we typically alert when things are on fire, right? If an error rate on one of our big services all of a sudden spikes and 1% of the calls are returning an error, that's a problem, right? If the latency spikes up by many milliseconds or hundreds of milliseconds, that would be a problem. And that's kind of wake somebody up in the middle of the night and make them figure out what went wrong with the deployment, that something's going on. But we also monitor error budgets. And error budgets we typically monitor over longer periods of time, often for things like a quarter. And we'll say over a particular quarter, your team is required to make sure that 99.95% of the requests are not errors, right? And an error budget is what you use to manage risk over a long period of time. If a team is doing well and they've had no problems and they're rolling out every week and they're not introducing any errors, then that's a time that they might be deploying a little bit more frequently, right? If they've had some problems and they've had a bunch of errors in the course of a quarter, you might say, you know what? You can't do any more releases for the quarter that are not quality related. And if you've ever been waiting on a Google feature from some team in Google Cloud and you're excited and they said, hey, it's coming in Q2, and then it didn't ship till Q3, maybe development took longer than expected. But what might have happened is that the team ran out of error budget in Q2, and they weren't permitted to ship their new feature because they had run out of error budget. And when you're running out of error budget for the quarter, you don't ship features again until you've fixed your infrastructure problems. So with ASM, we give you the tools to do both of these things: monitor when something is on fire, as well as that error budget over a quarter. Part of managing your error budget is canary testing. Part of that is if you're deploying a binary and it's going to throw errors half the time, and you expose that to all your customers, well, you're going to run up lots of errors, right, very quickly. However, if you're exposing only 1% of your customers to that new binary, and you can find that problem before it's affecting everybody, you've also saved on your error budget, right? Because you had a very small percentage of errors that actually got exposed. So canaries are when combined with the ability to monitor SLIs, are what give us the ability to really measure an error budget. And so I will quickly give a little bit of a demo of what this looks like in our UI. I'm going to switch back here, and I'm going to do a couple things here. I'm just going to show you our product health tab. In our product health tab, I have a couple of SLOs that are set up on this, and I can see that I have. I want to make sure that we are not having too high errors, and I can see I'm in compliance there. This is measuring errors. It's up at 99.5, and we've got 100% of our error budget remaining. We're not throwing any errors. That's great. I've got another SLO. Did I just click on the wrong thing? I did. Sorry about that. I have another SLO there that is set on latency. And there, actually, it looks like I am having a problem. I'm not out of compliance yet. However, oh no, I am out of compliance. Okay, I'm well out of compliance. Here's where there's actually a problem. And so this is a team that has now missed its error budget for this week. Here we have a very short one. But it can tell you. And we can also alert when you're on your way to being out of compliance. So this is an example of an SLO. These are very, very easy to set. The little red clock is telling me that I have spent my allotted time with my friends.